There is nothing worse than sitting on bed using your mobile phone, but then your battery drops. But luckily, you have one of those wireless chargers that you can use without even being irritated about all the charging cables and whatnot. Well, how does the energy transfer take place without a direct medium? Broadly speaking, there are three types of wireless chargers. According to David Green, a research manager with IHS Markit, there are charging pads that use tightly coupled electromagnetic, inductive, or non radioactive charging. Charging bowls or through surface type chargers that loosely coupled or radioactive resonant charging that can transmit a charge a few centimeter or uncoupled radio frequency RF wireless charging that allows electrical charge capability at a distance of many feet. Both tightly coupled inductive or loosely coupled resonant charging operate at the same principle of physics. The time varying magnetic field induces a current in the closed loop of wire. IKEA's wireless charging lineup, which includes the pads that are capable of charging three devices at once. It works like this. A magnetic loop antenna copper coil is used to create an oscillating magnetic field that can create a current in one or more receiver antennas. It appropriate capacitance is added to the loops resonate at the same frequency. The amount of included current in the reservoirs increase. This resonant inductive charging or magnetic resonance, it enables power transmission at greater distances between transmitter and receiver and increases efficiency. Coil size also affects the distance of power transfer. The bigger the coil, the more coils there are, the greater the distance a charge can travel. In case of smartphones, wireless charging pads, for example, the copper coils are only a few inches in diameter, severely limiting the distance over which the power can travel efficiently. But when the coils are greater, more energy can be transferred wirelessly. That is the Wireless Tri-City, a company formed by MIT a decade ago, has helped a pioneer its licensed loosely coupled resonant technology. For everything from automobiles to wind turbines to robotics, in 2007, MIT physics professor Martin Soliak proved that he could transfer electricity at a distance of 2 meters at a time. The power transfer was only 40% efficient at that distance, meaning that 60% of the power was lost in the translation. Soliak started Wire Tri-City later that year, commercialized the technology, and its power transfer efficiency has greatly increased since then. We can say that even today, wireless electricity is not completely modified to its greatest extent, but it can come in work in the near future. Well, as you all know, flying cars should be made lightweight. They can be powered wirelessly. So guys, that's all for the video. Thanks for watching and make sure that you like the video, share it with your friends and turn on the post notifications to make sure that you don't miss any of our upcoming videos.